last session, we have seen relationship between Cp and Cv, that is Cp minus Cv is equal to R, Mayer's equation. So in today's session, we are going to see numerical based on the topic. Along with that, what is flow process and non-flow process. This is Faizan Kagdi and I welcome you all to our lecture series of Basic Mechanical Engineering. So let's see our first question number 1. So as you can see on your screen, the question is displayed. Now it is 5 kg of air is heated from 25 degrees Celsius to 150 degrees Celsius. You need to determine first specific heats, that is specific heat capacity at constant pressure and at constant volume. Second, you need to determine change in internal energy, that is delta U. Third, we need to determine change in enthalpy, that is delta H. And fourth, we need to determine heat supplied, that is Q. It's given that you need to take R is equal to 0.287 kilojoule per kg Kelvin, gamma is given 1.4 and work done is also given, that is 500 kilojoule. So first of all, we need to write data given. So in a data, it is given in temperature is given in degrees Celsius. So we are going to work in SI system, that is international standard. So we need to convert temperature into Kelvin. Okay, so 25 plus 273, so it's going to give T1, initial temperature is 298 Kelvin. Then T2, there is final temperature 150 plus 273, that is 423 Kelvin. R is written, that is 0.287, gamma is 1.4. You need to find out Cp is how much, Cv is how much, delta U, delta H and Q. So let's proceed. Now we know the formula, we have derived it from Mayer's equation, that is Cv is equal to R upon gamma minus 1. If you remember that we have divided Cp minus Cv is equal to R by Cv, and from that we have obtained this equation, that is R upon gamma minus 1. Now in the data R is given, so substituting the values, we get Cv is equal to 0.7175 kilojoule per kg Kelvin. From Mayer's equation, that is Cp minus Cv is equal to R, we can obtain Cp, that is Cv is we have found out and R is given in the data. So Cp is equal to Cv plus R, that is 1.005 kilojoule per kg Kelvin. Now next, we are going to determine change in internal energy. So as we have derived the formula of maximum internal energy or the maximum energy that can be stored in a system is at a constant volume, and that was equal to mCv T2 minus T1. Now first of all, you need to see that is the requirement of an equation is satisfied, that is a mass given in a data. So yes, it is given, that is 5 kg. Is Cv is given, so yes, we have found out Cv. Is T2 is given, T1 is given, yes, it is given. So directly we can substitute our value, that is 5 into 0.7175 into 423 minus 298. So we get delta U is equal to 448.43 kilojoule. Now how we got a unit of kilojoule? So you have to see that the value of Cv, that is specific heat capacity at constant volume, is in kilojoule per kg Kelvin. So the answer of internal energy will also be in kilojoule. So over here unit is most important, you need to mention unit. Okay. Now next, we have also determined a formula of change in enthalpy that we have obtained is equal to mCp T2 minus T1. M is known, Cp is we have found out, that is 1.005, T2 is also known, T1 is also known. So we can directly substitute a value and we can determine delta H, which is equal to 627.81 kilojoule. Now last we need to determine how much heat energy has been supplied to a gas. So we can say a direct application of our first law of thermodynamics, that is our first law is Q is equal to delta U plus W. So we have determined delta U, that is 448.43 kilojoule, and W, that is work done, is given in a data which is 500 kilojoule. So substituting the value, we get Q is equal to 448 plus 448.43 plus 500, which is going to give 948.43 kilojoule. So this is our final answer of heat supply. So this question has been asked in your GTU exam. So I hope that you are clear with this question. Now let's see our next topic, that is flow process and what is non-flow process. So from a name itself, we can conclude that flow process and non-flow process. So flow is the one in which there would be a flow of a fluid or a gas, right? Whereas a non-flow process is a one in which there is no flow, or we would say a gas or a fluid is confined, where a system is not going to allow its flow across a system boundary. So what is flow process? So we can define it that a process in which there is mass as well as energy interaction between system and surrounding, then such process is called a flow process. So on which system this process is applicable? So we would say it is applicable on open system. So we also know the definition of open system. It is a system which permits energy and mass interaction across a system boundary. So the particular process is also called as a flow process. Now, what are the examples of a flow process? So we can say that we have an example of condensation process, right, in which a vapor is going to be condensed into a liquid state, in which a heat interaction and a mass interaction can take place between a system and a surrounding. Evaporation process, then we would say pumping process, that is circulating a liquid from one place to another place. We also have an example of a system, for example turbine, right, steam turbine, gas turbine. So what happens in a turbine? So a mass or energy enters into a turbine, it produces a mechanical work output, and after producing work, it leaves the system, that is, it leaves the turbine. Similarly, an example of internal combustion engine. Air and petrol mixture enters the system, do some work, generates a mechanical power, and after that, the exhaust gases leave the surrounding atmosphere through the silencer. Again, it's an example of an open system, that is a flow process, in which a gas crosses a system boundary and flows through it. Okay, so these are the example of flow process. Now, what is non-flow process? So we would say the process in which there is no mass transfer across a system boundary, but there may be energy interaction or heat interaction. So the most important term may be, which means there may be or may not be energy interaction between system and surrounding. Then such process is called a non-flow process. So on which system we can apply this process? So it is applicable on a closed system as well as on an isolated system. So again, we know the definition of a closed system. The system in which there would be no mass transfer, but it allows energy transfer or heat transfer across a system boundary. Whereas the isolated system is the one in which there is neither mass transfer nor energy transfer. So for that reason, I have written there may be or may not be. So if there is a heat transfer, which means it is applicable to a closed system, and when there is no heat transfer, then it is applicable to our isolated system. So basically in this chapter, we are going to focus on a non-flow process. We are going to study that process in detail. So let's see the types of non-flow process which are involved. So the first type of a non-flow process is called a constant volume process. What is called as an isoporic process, in which volume is going to remain constant. The example, the law which was given was Gay-Lussac's law, right? Then second is a constant pressure process. Even it's called an isobaric process. So the law for constant pressure was given by Charles, right? That is Charles' law. Then next non-flow process is a constant temperature process. Even it's called an isothermal process. The statement for this process has been given by Boyle's, that is Boyle's law, right? The next fourth one is adiabatic process. So we know that adiabatic process is the one in which there will be no energy transfer as well as mass transfer across a system boundary, which means this process is applicable to isolated system. Okay, and the last process is called a polytropic process. Again, this is the most important process. This polytropic process will cover all the above 4 processes. Because of that, this is called poly. Poly means multiple processes can be covered in this single process for various ranges of polytropic index. That we are going to study what is polytropic index. So now what we need to do in all this process. So listen carefully. In all this process, let's say for example in a constant volume process, first I would have to find out that how much heat energy has been supplied to a system during this process. Second, I have to determine that because of this heat supplement, is there any work output done by a system? That is a work done by the system or not? That we need to determine. Third, we need to determine that will there be any change in internal energy of a system because of this constant volume process. Fourth, we need to determine will there be any change in enthalpy of a system. And fifth, we need to determine pressure, volume and temperature relationship for this particular process, that is for example constant volume process. So we know that from Gay-Lussac's equation, the relation between pressure, volume and temperature is P1 by T1 is equal to P2 by T2, applying at state 1 and state 2. So this we have to do by using a combined gas equation, that is P1 V1 by T1 is equal to P2 V2 by T2. So in this equation we can say that since the volume is constant, so V1 is going to get cancelled out from one side and V2 is going to cancel out from another side. So what will be the final equation that will be obtained by combined gas law? So P1 by T1 is equal to P2 by T2. Similarly for constant pressure, P1 V1 by T1 is equal to P2 V2 by T2. So during constant pressure, P1 is equal to P2. So the final equation will be V1 by T1 is equal to V2 by T2. Okay. So you have to keep this in mind that in all these 5 processes we have to do 5 things which we need to find out. The first thing, how much heat is supplied. Second thing, is there any work done by the system or is there work done on the system? Okay. Next, how much is a change in internal energy during this process? How much is a change in enthalpy during this process? And what is pressure, volume and temperature relationship? Okay guys, so I hope that you are clear with what is flow process and non-flow process. In our next session, we will study all these 5 types of non-flow process in detail, starting with our constant volume process, and we will determine all these 5 things, and based on that we are also going to see the numericals on this topic. Till then, stay tuned and thank you all.